Welcome back to part 2. In this part we're going to look at the CAD process and how we take that CAD design and prepare it for printing on a 3D printer. So here we are, this is the CAD package I use, which is Fusion 360, and what we're going to do is design a subset of the chassis that's needed for the Simplex. I'm not going to do the full thing because it would take too long and probably wouldn't be that interesting to people, but I'm hopefully going to give you a flavour of what it is that we would do with one of these packages to create a moderately complicated shape from simple shapes. So let's get started. First thing we have to do is create a sketch. This is one of the faces of the object, so I'm going to create a sketch on this plane and I'm going to draw the base of the chassis, which is just a rectangle. So I've selected the rectangle tool. In fact, I'll select the centered rectangle tool and center it on the origin here of the plane, and I'm going to make it 13.5 millimeters wide and 28 millimeters long. These are just made up dimensions for this example. So that's our face. So I'm going to click on the finish sketch to say that I've completed it, and there we are. We have a 2D sketch of a rectangle. Let's just zoom it up a bit so we can see a bit better. Okay. So now what I'm going to do is I'm going to take that and I'm going to select the extrude tool, and what this does is it effectively pulls out that sketch to create a 3D object from my 2D sketch. So I'll select the tool and it's auto selected my sketch because there are no other sketches that can be selected, and I'm just going to type in the dimension this time 1.5 millimeters. I could use the arrow to pull it, or I can type it in, and there we are. I now have a solid rectangle which is 28 by 13.5 by 1.5 millimeters deep. By default all the dimensions are in millimeters. You can actually change that if you wish. So let's just have a look around our rectangle, and yeah, we have a nice solid flat plate. What I'm going to do now is use the inspect tool just to show how you might check a dimension. So in this case I'm clicking on 2 points and it's saying 28 millimeters, which is not surprising because that's what we put into our sketch. Okay, so let's now start adding to this. Let's create another sketch. This time I'm going to create it on this edge of our rectangle. So I click on it. Oops, didn't click. Sorry, click again. Click on it, and there we go. We're now in sketch mode. And what I'm going to do is put in some construction lines that are going to show us where the centers of the axles are. So I'm going to draw a line perpendicular to the base. I'm going to set that line to be 4 millimeters in from the edge. So I use the measurement tool to enforce that. There we go, it's just moved it across, kept it perpendicular. And what I forgot to do was actually set the length of the line, and I want it to be 10 millimeters. So I use this same tool to click on the two edges, pull out the dimension and type in 10 to set the length of the line to 10. So that's got us the first construction line that will show us the center of one axle. I now need to repeat the same thing for the other end, so I'll create another line about there. This time I'll actually set it to be 10 before I finish, saving me having to change it later, and I'll just get this to be 4 millimeters in from the edge as well. And in fact I put it in the right place to start with, so that's good. I don't need to do anything. And now I've got the two centers for the two axles. So the next thing I'm going to do is draw a couple of circles centered around those points. So I'm going to do a centered circle with a specified diameter. Now pull it out. Now I know the axles are 2 millimeters. The top hat bearings are 2.6 millimeters, and I want some material around the outside, so I'm going to set this to 2.6 millimeters for now. So I've pulled out my circle, and I can just type into that box the dimension I want for the diameter, which is 2.6. Sorry, 2.8. give us a bit more material. And I'll do the same there, and 2.8. Okay, so now what I'm going to do is create some rectangles. So select on the rectangle tool, which will connect those circles to the base. So I'm going to pull down into the base. Doesn't really matter where in the base I stop, as long as I'm inside the base, that's fine. So that will do for that dimension. I'll set this one to be 2.8 again, so it's the same width for the rectangle as the diameter of our circle, and I'll repeat the process over here. Again, it doesn't really matter how far down I go, and you'll see in a second why that matters, why that's the case. There we go, 2.8. And at this point I'm going to finish the sketch again. There we go, and you can see now we've got our solid base in our sketch. So I'm going to click on extrude. This time it didn't auto select, so there's several things it could select, and I'm going to select each of these areas in our sketch that I want to extrude. You can select any enclosed area to extrude, it doesn't have to be the entire sketch. And I'm using shift click here so that I add to the selection. Now you can see that it's got an arrow that would extrude out towards us away from the base. In fact, that's not what I want. I want it to go the other way. And I want it to go for 13.5 millimeters, the same dimension as our base. So I'm actually going to type minus 13.5 to make it go the other way. So I go to the box with the dimension in it, and I start to type minus 13.5. You can see there we go, it's extruded those shapes out. I've hit return, and that's it. We've now got a shape which is basically our base with some supports for where the axles are going to go. So I'm going to create another sketch now, again on this end face. Yeah. I'm going to create another centered circle with the same center. And this time I'm going to set it a bit bigger. So this is to give us some more meat around where the axles go, and I think 3.6. Now I think actually I might make that a bit bigger so we get a bit more material there. So let's make that, let's say 4 millimeters instead. And I'm going to do the same on the other side, on the other one. Again 4 millimeters. And I'm going to finish the sketch again, and then do extrude again. This time I'm going to select just that enclosed area, and the same on the other side. And again I want it to extrude the other way, so it's minus 13.5. And you can see now that I've effectively put a bigger circle around there, I've got a different looking shape. You can see how you can start to build up a complex shape. So the next thing I'm going to do is I need to be able to put the axles in. So I'm going to create another sketch on that same plane, create another circle. This time it's going to be for the top hat bearings, which are 2.6 as I said earlier. So 2.6 circle there, and a 2.6 circle there. Finish the sketch again, and then extrude, and then select the two circles. And again I want to extrude the other way, so I'm going to type in minus 13.5. But rather than creating a new body, I want to create a hole. So I want the operation to be cut. In fact, it's pre-selected it for me. I hit OK, and now what you'll see is that I've got two holes through those circles that I created earlier to hold the bearings, and that's where I'm going to insert the bearings. So that's the start of my chassis. I'm just going to clean this up slightly, because what I don't want is for the thing to be solid, because I want to be able to put obviously gears and all sorts of things, or pulleys rather, in the center. So let's do a sketch created on the edge. Draw a simple rectangle. Finish the sketch, and then extrude again that rectangle. So I'm going to pull it with the arrow rather than type in a number, and I pulled it all the way through, and you can see it's put the operation to cut again. So it's taken away that material, and I've now ended up with my axle supports. But because of the way I drew them originally with the perpendicular lines going straight through, I know that the thing is square and that each axle hole on each side will line up, and the distance between the centres of the wheels on both sides are the same as well. So I should end up with something fairly square. So I'm going to now use another tool. I'm selecting the little edge here, and I'm going to select the fillet tool so that I can actually pull out a fillet to give it some strengthening. I'll just do that again so you can see what I did. So let's turn it around a little bit, select the fillet tool, select that line, pull it out by 4, and you can see I've created a nice smooth curve there, which is just reinforcing really that joint. It's a very useful tool, the fillet tool. It'll do lots of things for you, so you can create these fillets like that, and you can create fillets on quite complex shapes. Let's do another one. What should we do? Let's do where that circle meets the upright. I'll do it 1.5mm radius fillets. There we go. And then you can also have fillets intersecting with each other. So if we move this slightly so we can see it, we'll select that line there and pull that one out, and you can see the previous fillet followed out with it, so that you've actually got quite a nice smooth curve in 2 dimensions there. You can also use it to go the other way. So if you want to sort of pulling out a fillet, you can round a corner by, let's select this edge here, which as you see is actually quite a complex path, and we're going to move it in by 0.5. Let's zoom that in a bit so we can see better. As I rotate it, you'll see just how it's rounded that quite complex path and put a rounding on it. Useful if you want to take sharp edges off your design. Well, there we are. Hopefully you'll have seen that you can fairly quickly and fairly easily, with the use of only a few tools in this case, I've drawn circles, rectangles and straight lines, and then I've used the extrude and the fillet tool, nothing else, and created a fairly complex looking shape. And you can build up more and more shapes. You can add more materials, add more shapes, and remove them to create holes. Then you can be round holes, they can be any shape that you've designed. So hopefully that's given you an idea of what you can do with a CAD tool, and showing you it's not as difficult as perhaps it at first sight appears. Okay, so moving on then, what are the next steps? We've got our design. In fact, this is the design here on the right hand side. What we need to do once we've completed it is prepare it for printing. The tools that come with printers tend to need these files called STL files, which are a particular format, and you can export it directly from a tool such as Fusion. There's just a file export option, and it says STL is one of the options that you can export it as. Once we've exported that, we import that file into a program that came with the printer, which converts the CAD design into commands to send to the printer, and that's what we're going to do next. The program you import it into is called a slicer. And what does a slicer do? Well, it creates slices of each print layer. So effectively it takes your 3D object and it converts it into a number of slices that will be printed one at a time on top of each other by the printer. So here you can see our design loaded into the slicer that comes with my particular printer. And the first thing we'd do is orientate it, so you decide which face you want to put down on the print bed. Now there are reasons for choosing particular faces. If you've got one face that is much flatter than any of the others, then that's always a good one to choose. If you've got one which is much bigger, so it's the one that supports the rest of the print, then that's a good one to choose. That brings me on to the next topic, which is support material. And this is how you the print to actually be supported and a solid object, and we'll look at that in detail in a second. You can also control other features such as infill. When you print something with a 3D printer, you tend not to make it of solid material just because it uses a lot of material. So the way they work is they have almost like a honeycomb center, if you like, so that you use less plastic to build it up. It saves on plastic, but it has some downsides. For instance, it can weaken if you have insufficient infill. Although you don't need that much, typically 20% is a lot. 15 is quite common to use. You have solid edges to everything, but you have infills in the middle. You can support set other parameters about the print as well. For instance, you can do something called ironing, which is where it uses the hot print nozzle to try and flatten out horizontal surfaces to take away some of the texture that you naturally get when you print with a filament. There are lots of parameters like that. I'm not going to go into all of those parameters. Support material, however, is something we really need to understand because it does make a big difference. So what is support material and why do you need it? Normally in a print, each layer is supported by the previous layer. As we're building it up from the print bed, every layer sits on top of another layer. Of course, if you have overhangs in your print, there is no layer below to support it. So here's part of our design, and you can see we've got overhangs. So I'll use my mouse. You can see the pale green material in the horizontal layers is support material for the slightly darker bit, which is the bit that connects to the actual print, and the actual print is shown in this reddish colour. The blue layer bits are something called enforcers, which are to do with where you've got angles in your print. You can get away with a certain amount of overhang. So if you've only got a very gentle introduction to the overhang, you can find that the previous layer is enough to support it. So if you, for instance, got one layer of filament that comes out at less than 45 degrees, it will normally get supported on the edge of the previous layer, so you can manage without supports. The supports themselves aren't completely connected to the prints. On some printers you can have two different types of filament, one used for support and one not, to make the supports easy to remove. On the more hobbyist end of the market, you tend to only have one print head with one type of filament. So the way this is done is where the support layer finishes and the layer of your object starts, you have a very small connection there to make it very easy to remove and clean up afterwards. There are also different types of supports. So you can have supports that grow up from the base of the print bed only, and interior supports. Interior supports tend to be harder to remove just because they are built on top of a layer of your actual print rather than on the top of the build plate. But you do sometimes need to use them depending on your design. If you have big hollows in the middle of your design, for instance, you may need to use internal supports. But it's something you can play around with when you do your print and see how it affects your print. Very worst case, you end up with trying to print something in mid-air and it will just collapse in and you'll get a failed print. Okay, so that's the CAD process and some of the preparation for printing. I think we'll leave it here for part 2, and in part 3 we'll come back and we'll look at the final design for our chassis, for our Simplex, and the finished article itself. Thank you.